So, hi guys, good evening, everybody. And yes, welcome back again, another masterclass on Kubernetes the hard way. I'm sure you all are, listening to me because I can see the response for the YouTube. And yes, one hello and voice is not coming. That's it will be, I believe, voice and everything. Not audible. Maybe you need to wait for a few more seconds just to be on the same page. ऐसे ऐसा होना नहीं चाहिए. Now audible. Okay, that is great. So I hope आप सब अच्छे होंगे. And this masterclass is for people who want to start their career in the new world of IT industry, that is containerization process, right? And I'm sure आप में से कुछ लोग कंटेनर्स के बारे में या क्यूबरनेटीज के बारे में जानते होंगे, मे बी बहुत सारे लोग जानते होंगे. So what we are going to do in this master class, that glimpse I can give you in one shot. तो इसके अंदर हम लोग जो ट्राई करने वाले हैं कि मास्टर क्लास में हम एक्चुअली क्या करेंगे. सो इफ आई क्लिक हियर तो आपको क्यूबरनेटीज के बारे में काफी कुछ आइडिया लगने वाला है. आई एम नॉट सेइंग कि हाँ बहुत सारी इंफॉर्मेशन मिलेगी, बट यस, you'll be having a lot of information about that. And after that, if you go to the main topics, इनके बारे में हम कुछ examples, कुछ demos, ये सारी चीजें करने वाले हैं. And definitely काफी useful है अगर आप IT इंडस्ट्री में किसी बड़ी कंपनी लाइक पेटीएम, गूगल, माइक्रोसॉफ्ट पे एज अ प्रोजेक्ट या फिर ओपन सोर्स में कंट्रीब्यूशन के कॉन्टेक्स्ट में कभी देख रहे हैं तो, राइट? My thought is not good that, but okay, ठीक है. So now the point is, एक छोटी सी story है how we can think about applications, right? तो मैं एक PPT यूज करूंगा आज के टॉपिक को एक्सप्लेन करने के लिए, या फिर हम लोग इस मास्टर क्लास से क्या सीखने वाले हैं. And आपको एक assignment भी मिलेगा. That assignment you have to perform, and on behalf of that we'll be having some a certificate from our end. जब तक आप perform नहीं करेंगे तो वो certificate नहीं मिलेगा. Okay, so I'm taking it slow, and खासकर वो लोग जो अपने आपको इस डोमेन में रखना चाहते हैं, या फिर if you want to be one of them who understand the technology at very beginning level, so that can be one of the good part. So I can just remove this drawing by this one, and I'm having one of the beautiful software by another company. So पहली बात तो ये master class is useful, right, for the people जो लोग already cloud computing जानते हैं, पहले डोमेन में वो लोग हो गए, राइट? सेकेंड काइंड ऑफ पीपल, इफ यू आर अ वेब डेवलपर, राइट, आप काफी अच्छे से वेबसाइट डिजाइन कर देते हैं, और मे बी यू वांट टू स्टार्ट योर करियर इन डेवऑप्स, तो वहां भी आपको काफी सारी चीजें मिल जाएंगी. आई थिंक आई कैन जस्ट चेंज द पेज एंड राइट देयर. थोड़ा सा मुझे इजी रहेगा यहाँ पे लिखना. So this master class is for every people from every industry, right? And people who are from web developer background, that you can understand how these days things are going on. Definitely, a number of things need to be taken care. But yes, if you're from this domain, you can talk about that. And if you are a software engineer, that means you love programming all the way, and how this industry is going to change a lot of things for you guys. And if you're from cloud background as well, so you'll be having a lot of ideas, okay, how things are getting changed. And let's say you are someone who's a little confused how we can plan this master class. outcome, right? So basically, जो भी होने वाला है सब कुछ already well known है, and you'll be getting the recording, you know, असल YouTube पे live है तो recording की कोई बात मैं क्यों कर रहा हूँ, but yeah, so let me settle down first. So I'm gonna use one of the PDF and to make you understand कि पहले हम लोग IT इंडस्ट्री में कैसे थे, nowadays these days how we are moving forward. So for this purpose, what I'm trying to do is I'm going to use one of the PDF and that will be this training. So सबसे पहले एक बहुत important aspect है समझना, and that aspect is कि एक बार के लिए हम मान लेते हैं कि हमने कोई भी एक एप्लीकेशन, राइट, इट डजंट मैटर कि आप किसी भी एप्लीकेशन बैकग्राउंड से हैं या नहीं है, तो मैं यहाँ से स्टार्ट करता हूँ, राइट, एंड इमेजिन दैट यू गाइज आर फ्रॉम सम ऑफ द एप्लीकेशन बैकग्राउंड. तो अगर देखा जाए तो आपके पास एक सॉफ्टवेयर है, कलर थोड़ा सा चेंज करना पड़ेगा मुझे, एंड आई एम मेकिंग इट ब्लैक. आपके पास कोई एक सॉफ्टवेयर है या फिर कोई प्रोजेक्ट है, जैसे कि कहीं भी आपने कोई प्रोजेक्ट बनाया होगा किसी कंपनी के अंदर, या फिर आपके पास कोई एक कोड है. इस कोड को आपको डिप्लॉय करना है. पीपल हु आर नॉट अंडरस्टैंडिंग डिप्लॉय, you can talk about run, if you want to run that code. Okay, so how we have done things in the past. So simply, let's say I have one of the application written in maybe ASP.NET, maybe in Java, maybe in Python, maybe in PHP. It doesn't matter at all, right? So I have an application is written in any of the platform, like .NET. I can assume PHP, or maybe I can assume a Python-based application as well, or maybe it's a very very much normal application. So how we have to run or test or deploy this application, this is one of the concern. Okay, and to understand that whenever we are having some normal website with some good content, or maybe with some good programming front-end and back-end language along with database, the concern is how I'm going to deploy it or test it or run it. When I know things, I can do it better. So this journey we are already living. That means maybe 80-90% people already have idea, okay, if I have .NET application or PHP application or Angular application, then you can deploy in Amazon Cloud, right, by using some service. Maybe you can deploy in GoDaddy server, Linode server, DigitalOcean. We have number of options, but we have to track down every single record where and how we have started. So whenever we have some application, right, and that application, if I want to deploy it, the first method people started using was this. Okay, so let's say I think more than 20 years it's been that people were using this method. So they used to purchase one hardware, like everybody did, and they install operating system. Let's say I want to deploy or run my .NET application, so I will install the .NET framework here and run it, and that application is running fine. In the same hardware, if I want to do deployment of PHP application, I can do that. Similarly, a Java-based application, I can do that. So this process, purchasing a physical machine, installing operating system, then setting up the entire platform is gonna take time. And when you are taking it, simply, it's a slow process, because you can understand that feeling. Even if you're going to buy a laptop, it is a physical process. You have to go test, take care of a lot of things in your mind. Then you did that thing. And after that, the overall time you're going to consume. Purchasing a new hardware is not a one-time task for a company. Okay. That means for a student and for professionals also, you are just purchasing a laptop that may have configuration up to 32 GB or 64 GB RAM with 8 or 12 core CPU. But for a company, when the entire developers community, they want to deploy their application for testing purpose and for production also, they need a big server, right? Where they can deploy databases, application, front end, back end, API, anything. So for a company, it's a huge cost that is going to be involved. So these are the points that we have already done it in the past, right? Already done it. That means there is no issues in this. And definitely if a company is investing too much and initially only 2 or 3 applications are running there, then you are unnecessarily wasting resources. Because if you're not using it, maximum server is free. So definitely it's a waste of resources, right? And you cannot purchase small servers because you need then more management, power cable connections, so many things are there. And this is also a problem, difficulty in scaling. If you purchase one server with small configuration and you want to scale it, that means you want to increase the RAM or the CPU or maybe anything else. This process is not that much simple. Imagine in your mind, if you purchased one laptop with 8 GB RAM, right? So imagine this is you, okay? And you purchase one laptop with 8 GB RAM with 2 core CPU. And after few months, you want to increase your RAM and CPU both. So this process is not that simple. You have to go test, okay, how much possibility is there. And when it comes to possibility, you have to invest some amount, time. The most important thing is you have to shut down your laptop. So when you shut down, whatever application is running, it's gone. I mean, gone means not live. So simply history in the past, I mean, we have done things likewise. And that time, if my application is live, increasing the primary resources like CPU and RAM was really not easy job. Okay. And vendor locking, we're not talking about this, but yes, at least you are understanding 1, 2, 3, and 4. 4 big process. Okay. So, I mean, yeah, I don't know. I mean, if you guys are listening, you can respond me back over the YouTube, because I can see my YouTube link as well, that these are the major complex problems we have seen. And yes, if you are somewhere agree on that point, better to respond it back. Okay. Now, let's say you have one big physical server and you're planning to deploy your 3 applications, 1, 2, 3, that is, .NET, PHP, and Java. Okay. And for some reason, what is happening when you're trying to deploy the Java application, maybe the Java is not compatible with .NET. Okay. And when the Java is not compatible with .NET, imagine that there could be any reason. Any reason means any reason can be there, right? If they're not compatible, that simply means there is one room, one server, one place where 2 people are not compatible to each other. They cannot sit there. So simply in the world of application also, when they're not compatible to each other, it's really not easy to manage their existence on the same server. And you know what? You already invested a lot of amount of time and money to purchase and buy the new server. And what the hell is happening is .NET application is not compatible with that Java or maybe anything else. So simply, it's not easy job at all to maintain this entire process. So as a solution, from back 20 years, if we talk about these days, what solution we are having. When two applications are not compatible to each other, and we have a lot of resources spending in my physical machine, in my server, in my laptop, and the issue is compatibility. So solution by people, what they have introduced, this technology. I'm sure a lot of people, you guys are already aware about hypervisor and this, virtualization technology. So it's a hypervisor based virtualization. Whenever there is a incompatibility, right? That means application 1 is not compatible with application 2. Definitely, what you can do, this physical server, you have some OS and install some hypervisor. We are literally not going to discuss about hypervisor, but people who are not from this tech background, hypervisor background, I mean, the software like you guys are using, let's say VMware or VirtualBox product, okay? VirtualBox. These are hypervisor software, right? So now these VMware VirtualBox software is giving you the option to create a separate operating system on the same hardware. So if you talk about the definition, one physical server can contain multiple applications without any conflict issues, and each application runs in a virtual machine. So virtual machine means another operating system, but not in the real hardware. It is going to be on top of something, we are calling it hypervisor. So they are running it virtually. So now what people have adopted, my .NET application will be running here, my PHP application will be running here, and my Java application will be running here. So when they have their separate operating system, there is no chance of incompatibility, right? So to understand this problem from a mental point of view, I'm going to give you one simple example, okay? Let's say your father designed or purchased one land, and now you have a land where you and your brother and your sister, mother, everybody, you guys are living. So you don't have any privacy, right? You are not compatible to each other, so you'll fight. So what solution your father did? Simply, they divided this bigger land into smaller rooms. Now the land is that much only, but we have room 1, room 2, room 3, and room 4. And now everybody is having their own space. Whatever they want to do, they can do it. So the same job is done by these virtualization software called VMware VirtualBox, or you can call it hypervisor. On a single laptop or single physical machine, we are installing number of small and virtual operating system. And then when they have their private space, there is no chance of incompatibility. And trust me, guys, the concept of virtualization gives us a lot of benefits. That means a lot of benefits means, yes, nowadays one single physical server can have number of virtual machines, right? So unexpectedly, this discussion is why I'm doing, because where I want to take you guys for that thing, these two things are platform. Number one, in earlier days, we need to deploy things on physical server, right? After that, we move to hypervisor or virtualization because of incompatibility in the applications. Now, definitely, the problem was in back days to purchase new hardware. It was time taking, and this time it's really fast. Okay. So again, I'm watching your comments on YouTube. If you guys are understanding this set of mind and the problem, what was there, and we got solution by hypervisor or virtualization. So simply a single server is divided into number of VMs, and we are living in the concept of virtualization. So please do comment over the YouTube if you guys are understanding it well, and you got that yes, this solution is working for number of companies. In fact, billions of people, they're using hypervisor technology, or I can say virtualization technology for since number of years. And this technology is given the benefit of these things. Now you have better resource pooling, right? A number of VM. In fact, the concept of cloud computing came due to this virtualization technology, right? So simply, virtualization is amazing. I mean, you might have seen that, VMware, VirtualBox, KVM, and so many things, right? But the most important thing, right? Most important thing is, what is the problem with the technology? So we had problem with physical server, okay, physical server, and we moved from physical server to VMs because we had problems, right? What sort of problems we had that you just have seen? I will be sharing this PDF, by the way. The slow time, huge cost, waste of resources, and blah blah, right? And then you move to the virtualization concept. So definitely, if you have some problem with VMs also, then what's next? So now it's a movement of technology from virtual machine, from physical machine to virtual, and virtual to something else. And that something else is our damn topic of today, right? Trust me on that. And you're gonna enjoy this, right? So this really, small chunks, point, gap in the mind is gonna give you the goosebumps, right? Yes, we have to understand it. So when we have problem, then only we'll think about solutions. We're not, thinking about solutions like that. So now let's try to understand in 1 minute, what is the problem with virtual machine? Okay, but before that, let me ask you one question for this. So if you talk about yourself, okay, for me, I am purchasing a laptop. Let's say I have MacBook, and I'm purchasing my MacBook, and I'm a normal human being, right? And being a normal human being, this MacBook is giving me so many features. That means I can code here, I can do web browsing here, right? I can, watch movies. I can watch movies. And in fact, I can listen music, or I can play games. It doesn't matter you are having MacBook or your Windows machines and your, Linux machines, right? Whatever you are having. So these are number of things, right? So simply, when a single laptop or device I am using or you guys are using for multi-purpose, right? That means your laptop you guys are using for your coding, for your games, for your movie watching, and I don't know what extra things, right? But that is multi-purpose. But think about it. The same thing is not happening with your company server. So let's say if you got selected for some big organization like Amazon or maybe for Microsoft, okay? So Microsoft will give you a laptop where you can do all these things. But when you code a project or a product, they have servers, okay? They have servers. And this server is literally not for your web browser, not for movie purpose, not for games purpose, in fact, not for coding purpose as well. Because you do code on your laptop, on your system, and you put it somewhere like on GitHub. But this server is for either testing or maybe running your code, or maybe make it live for production. like we have some websites, something. So these servers are something that hold your data, and we don't need any extra software. Otherwise, it is an unnecessary burden on the server. So let's say if I'm having a Java code, or maybe I'm having a PHP code, and I want to run or test on this server, I just need operating system, only that operating system that support your PHP. If I want to test for PHP only, no unnecessary things. That means I don't need my software notepad. I don't need any browser. I don't need any media player. I don't need my computer, games and all. I don't need anything apart from the only one support. So if I'm writing my code in PHP or in Java, in Python, I literally want to run that software, damn software in the same in server, right? So when you understand this entire scenario, so why people are saying the server is on the black screen, or it's a Linux, or it's a Unix, because we don't want to keep any extra software on that machine. They have a dedicated purpose. And sometimes the concept of dedicated computing comes in picture, right? So I purchased one server that can only host PHP or Python or Java. That's it. No graphical, nothing is there. I don't need it, right? So now you understand one thing. So when you understand this thing, let's go to the concept of virtualization. What are the limitations that we are having in the virtualization? Any virtual machine that you are going to use it, or you're going to talk about, if I want to create any VM, for VM we need OS, and the kind of operating system choices I'm having, either Windows based or Linux based or Mac based. And when you install these OS, you need again CPU, storage, RAM, and the most important point is entire guest operating system. So that means you might have realized whenever you're installing OS in your virtual machine, it is coming with all the software, notepad, browser, my computer, blah, blah. I don't know what other software we're having. Okay, and trust me, from the last discussion, see here, from the last discussion we have seen, we don't need this thing if I'm dedicatedly running my code or testing my code. I don't need this. So the virtualization concept is giving you isolation, that means privacy, so that you can get rid of the complexity of software conflict. But when you have some unnecessary software like notepad, my computer, blah 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 blah, but this virtualization is not giving you that freedom. Fine. So we need something that can give us only that part of operating system with only PHP support if I'm a PHP developer, or with only Python support if I'm a Python developer, or with only Java support if I'm a Java developer, right? So simply, virtualization is good, but we are unnecessarily using that OS with extra software that is not required by this. So imagine, guys, imagine this thing once, right? If I want to run Java program, do I need a notepad? I already have written my code. No, I don't need. Do I need my computer? No, I don't need. Do I need browser? No, I don't need. 99% things I am not looking for if my intention is only to run my Java code. And when it is there, this feature is not given by neither physical machine nor virtualization. So that's the problem with virtual machines. In fact, virtualization is more about isolation, dividing one bigger server into number of VMs so that you can run things easily. But operating system complexity and unnecessary part of software is going to get that. So I'm sorry. If you're understanding this concept, just one yes message on the right YouTube chat window, and boom, we're going to launch the technology, right? So here, me as a developer, if I have a code and I want to run it, I don't need physical server these days because there are complexities. Then VMs also, and we have seen the complexities, right? So simply here, now the way we are going to talk about is containers. So now we are moving really fast. I'm rejecting the past previous experiences, boom, boom, and we are going with containers. So now here, my first topic is landing. We are just discussing about things, right? So we don't need VMs or physical machine just to deploy my code, and we are going to use container. Now container is something that you have only required part of OS with your code. That's it, right? That's it. We have nothing. So simply, how we create container, and if you just try to understand this, we used hypervisor or VMware VirtualBox hypervisor. And an example, if you might have seen, you have used VMware or maybe VirtualBox and many more things like that to create virtual machines. So how do we create container? So like we have hypervisor as an option, like this one. To create and manage container, we have CRE. And what is CRE? CRE is Container Runtime Engine. So it's a container runtime engine. Run or runtime, both is fine. Runtime engine. Okay. So try to compare this. To create virtual machines, we have hypervisor like VMware VirtualBox. Similarly, to create and manage container, we have CRE. And under CRE, what are the options we have? So one of the good example you guys can use is Docker. So Docker is the one that can create containers along with your code for you. Apart from Docker, we have another one called Podman. Or I have another one called Cryo. Many other options are there. So the one I am using right now is simply Docker and Podman. Docker, I'm not going to use it for this masterclass. I will be using Podman for this, right? So simply, Podman is one of the good and amazing container runtime engine, right? And that is one of the things. So one demo I'm going to show you for Docker, another demo for Podman. So let's say if I'm just going down and I already have Docker ready in my machine. So here I'm going to erase this, and if I'm going to log in into my machine, this is one of the machine, and here I already have Docker pre-installed. Okay, so installation is not my target, by the way. So if I check Docker version, this technology platform is already there, and there's no problem. So let's say if I have some application, how much time I'm going to take it to deploy it. So just to show you, I'm going to take a sample application. It's a sample GitHub code from here, and I can take the first one. I generally take this example. So this is one of the sample website that I have, and if I want to deploy by using Docker technology, first of all, I'm taking this software in my local machine, and if you just wait for it, I can see this code is here. I'm renaming it like HTML code, and let me now do it. So now I have the code called HTML code, right? HTML code right here. So what I can do, see, by Docker technology, Docker run, do not try to understand this web site and 80-v. Then I'm going to use home fire HTML code to something. So you need to understand this, but I want to show you the speed and the power and the resource consumption. And done, right? If I can show you Docker PS, the container is running, and see, I can go to my IP address, colon 4455, and yes, I have the code. See, that means hardly it is taking less than 1 minute to take some code, run it in a container. Do not worry about, right? The command I'm typing, that is all not useful for now. But the important thing is to understand. See, so that much time is required to deploy a website. In fact, if I make some changes here, let me do it for you on the real time. So I'm going to my HTML code. I'm making some changes. Let's say Mozilla is cool. So Mozilla is cool, but Docker is awesome, right? And I can close it, refresh it. Whoa! See, I refresh it, and it's changing on the real time. So that is the power of container, right? So now you got that idea. Basically, container is giving you two things. Speed, they're very lightweight, very tiny. I can show you the size of entire container is near about Nginx. It's 133 MB. If you look at this, the size of my entire container is 133 MB. And here my website, my OS, everything is there, right? So definitely number of things, number of process will be going on in your mind. But my target is to reach you guys on Kubernetes first, right? Then we'll talk about anything else. So can I get some input from your end that yes, you are understanding the simplicity, okay? Because see, if that much small time and one single command, one single operation, this can be also graphical, right? Can give me the freedom to host my website in fraction of seconds. Isn't it very lightweight? And look at the resource. I mean, how much RAM and CPU I am consuming for this. I can give you that idea as well. See, my entire website is using only 7 MB RAM and almost zero CPU. Very few percent. 7 MB RAM, oh my God. See, the limit I have in my system is 32 GB RAM. And 7 MB literally, in 7 MB, your tiny operating system, along with your HTML code, along with this networking and everything is going on. And it took fraction of second to deploy. And guys, that is the power of container, right? So simply, the container is nothing. It is giving you platform to please come and test your code and host your website and do whatever you want to do. That is the damn power of containers. And man, look at the resources. Literally, so awesome. 7 MB, 8 MB, I don't give a fuck about it, right? 7 and 8 MB is really, really, really tiny. When that much tiny, you don't even think about 8 MB RAM. Oh no, okay, good. So that is the power, right? So I don't know if you are understanding my excitement or not, but these two commands, one for this thing, another for stats, right? So I hope you are understanding it, right? So when we shifted to containers, we got two big things. The first, they are very lightweight. 133 MB is really, very tiny and fast. They're literally fast. And the time I invested, literally, if I calculate the real time, that is not more than 5 seconds to deploy any website in the world in containers. It's literally, I'm giving you my words, right? You can come to LinkedIn and can have a discussion. But lightweight, fast, and ultra easy, right? So we have some problem with container also. Like similar to this, Podman is also there. I'll tell you that, right? Now going back to one more thing, when it is really easy to create container in that much amount of time, there is one more problem. See, I can write, or developers can write a for loop for I in and let's say sequence of let's say maybe 100 containers. Okay, and I can write, okay, I want to create 100 containers from image, right? Don't worry about this. And when I do enter, see, every single second we are creating one operating system. See, and the process is going to be really fast. If I go back to my SSH and 1, 2, 3, 4, and if I do Docker PS along with the watch, you will be able to see that how fast we are creating containers. See, just keep watching, keep watching. You will be creating these many containers in microseconds, right? So if the screen is getting refreshed, see, 1 second, less than 1 second, less than a second. Oh my God. And this is all happening. I'm creating 100 containers and it's all done. Even it is not taking 100 seconds to create it. And that's simply that method. So, oh, okay. So these many containers, see, you can see that Docker PS, I have 100 containers. You cannot think about creating these many OS with the code, with the data in that much fast manner. Okay. So the two things. First benefit is we are literally having freedom to create any number of them. I mean, your single system that has 8 GB RAM, you can create 1,000 of container in few seconds, right? If you have the right knowledge. And definitely every container can have your different website, different code, different language, different things. It's really fast. But you know what? What is the problem? I cannot remember or I cannot understand which container hold what application. See, we have these many containers. The most important thing is how do I manage? How do I manage? That means if someone is saying, okay, my code is not working, I have to figure out which container is related to you. So when you have this freedom, we have the ability to understand things. Definitely the problem is management. I mean, literally you can think about it. If you have 200 PCs in your laptop, in your lab, managing them and remembering them, which PC running what application, which version, which software is really a frustrating job, right? So if I can create 100,000 of container in few seconds, in few minutes, how do I remember which container is having what application? Or if a particular container is down, how do I figure out and troubleshoot and make it up? That means apart from management, we have security problem also. Which container got attacked and how do I remember? I have to I have to set up some alert, some monitoring, something that I can figure out. Okay, this container is not behaving well. So Docker or Podman giving you the option to create container, but management of these many hundred and millions of container is not at all easy, not at all easy, right? So simply, now we have reached to the level that if we can think about deploying code, physical machine is not good, VM is not good, containers are awesome, but about the management of these many container is literally not possible, in fact. And that's why my friends, this problem is generally we are calling as container orchestration problems. Okay, that include a lot of things, right? Include a lot of things: management, security, remembering, scaling, troubleshooting, monitoring, and blah blah. I mean, what not, right? We're calling it container orchestration problems. And orchestration is a problem that arises when we use the container. But that's not a problem of Docker, because Docker said, okay, you bring me here to create containers and I did my job. So now you are not capable to manage these many containers. It's not my problem. And in fact, it's a genuine one, right? If you're purchasing 3,000 PCs, then the shopkeeper will give you those PCs and laptops, but you're not able to manage it. That's not a problem of them. That is another problem, and we have to solve it, right? Isn't it? I mean, you are understanding this part. In this entire cycle, Docker giving you the option to create containers, but you're not able to manage it. So this is not a problem of Docker. This is a problem of you, and you have to find a solution. And that's where the container orchestration engine and tool will come in picture. Now, the rest of the discussion is going to be on that context or on behalf. Okay, so if you guys are understanding, you have the platform YouTube, please do comment it that Docker is not responsible for this thing if you're not able to manage your containers, because it's the problem that you generated. Okay, so all right, I'm going back to this. Let me just first delete all these containers. So what I'm doing is that's fine. I can delete all the containers, but I'm not deleting it, right? I have a lot of system, resources, so many things, right? And now, when another problem arises, and we're calling it container orchestration problem. So container orchestration. I'm sorry for my handwriting, but yeah, that's how I'm really bad at, right? Container orchestration. So we have some container orchestration engine. Okay, and these orchestration engine are, we are having a list in the market, right? So if you guys want to solve that management, security, scheduling, troubleshooting, monitoring, all those problems, we have number of options for orchestration purpose. One of the option is Swarm. Another option is Kubernetes, and another option is OpenShift. Although OpenShift is more on more about using Kubernetes, but we are not going to discuss about any of them except Kubernetes. Now, it's a very amazing product by Google, right? So Google is using a product called BORG in their internal things. And due to this BORG, the open source idea is Kubernetes. So Kubernetes is a product that is written in Golang. And initially it started by Google. Now CNCF is taking over this. So that can deal with those problem of container orchestration. So it can plan, number of things for you. So simply, these are the things that you can understand or think about. So now our discussion is going to be on Kubernetes. So we're done with the container process. These are things. I'll share this PDF with you all. In fact, I downloaded it from Google, so you can download it because I'm really bad at creating the presentations and all. So Kubernetes is container orchestration engine, and that handle container operations and management, scheduling, security very gently, very smoothly, in fact, right? So now if I'll just minimize this thing, and let me just take that PDF for you. And here we have another PDF, right? So this PDF, I have downloaded it again. This is not by me at all. And Kubernetes. Okay. So simply, Kubernetes is a way and is a project by Google. Okay. And that really got, conceived from one of the amazing idea by Google. It's a startup, right? And when it comes to orchestration, Google has given its 100% effort to make it very ready. And this is one of the system binaries that you can understand. Okay. So yes, I'll be giving you this PDF, both the 1 and 2. So now you have to understand how Kubernetes is maintaining all these containers. Okay. So to make you understand this thing, how Kubernetes will do that job for us, I'm gonna remove this. Okay. So we have to understand the architecture of Kubernetes. Okay. So Kubernetes saying you guys can have number of machines. It can be physical machine, it can be virtual machine, it can be cloud machine, and whatever number of machines you are having. And in those machines, you guys can install any container runtime engine platform, any platform. The beauty is any CRE. Now, if you skip what CRE means, container runtime engine like Docker. So let's say any CRE software you install on these machines. Okay, so it can be like it can be Docker, or it can be Podman. It can be and different CRE in different machines. Maybe it can be Docker again. It can be container D, or maybe Cryo, right? It can be Rocket. These many things. And in which container I want to plan my application, that's also not a big deal for you. So Kubernetes has one system, and that system is going to be here. So now Kubernetes has the power and technology to handle all these machines. Okay, and this is called as Kubernetes master node or master system. They are master and they are minions. So now what you have to do it's in fact very interesting and easy. So as a developer, this is me. And what I did, I had the code. With the code, I have to make one, Docker image. Or in fact, I can say I have to use any Docker or Podman technology. And when I use it, I need to create one image. Which image? Container image. So the code, if you want to run in a container, definitely you need to create an image. And when you have the image, you can ask Kubernetes. You can ask Kubernetes master, okay, you have that container image and you want to deploy it. People who are not aware about deployment, you can say you want to run that code. So you give it to your master. Now master have number of components internally to handle it. We don't have that much time and that much agenda also beside, but I can tell you the intelligence, right? So simply this master node can choose automatically without your interaction, right? It has that power. This master node, you just have to, tell to your master node, and okay, this master node will automatically choose any of the system and create your container here. Okay, create your container here. So simply, your master node is going to be something like we are having, master these many machines. I'm a developer. I can, write my code and do boom, 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 and that's it. See, I will be showing you that demo, but to understand that thing, we have to think one more process, right? But it's very awesome and sweet. So I'll be taking one code. I'll be converting that code into image, and that image is going to be, I can, upload it somewhere, and from where my Kubernetes can take from my instructions and go and deploy it in any of the listed machines where Docker or any other container runtime engine is running. Okay, so but how will prepare this infrastructure? Because once this infrastructure of master and minions is ready, then only I can do that, right? If I don't have that infrastructure ready, how do I do that? I think I'm audible, right? Because somebody replied that I'm not audible at all. Isn't it, guys? I mean, is the case? So. Yes or no? I mean, just respond me there. So now the entire discussion, we are going to talk about how we build image practically and how we deploy it in Kubernetes. So the entire 1 hour things is dedicatedly for building images using different tools and Kubernetes, right? So I'm sure I'm audible and it's not a problem at all. Okay, cool, guys. So the question mark is, how do I deploy it? And here is the answer. So I can take that input and go back to this. If I want to deploy it, let me go back to my browser again, right? And if I go back to my browser, right there, oh, that's nice. See, so if you look at this discussion, we have that idea, okay? And that idea is about Kubernetes, the origin from Google BORG that we have done. Now, cluster deployment methods. So there are 3 category people. First, students. Okay, if you want to deploy a small version of Kubernetes, you have 2 things. First, either you have your laptop or you have Raspberry Pi. if you might have, aware about Raspberry Pi. In both things, you can deploy Kubernetes cluster. That, that design we discussed about, this one, right? You can deploy in your single laptop as well. That is definitely not having all the features, but you get a feel about it. So if you want to deploy in your laptop, in your laptop or desktop, we have something called Minikube. Okay, Minikube. Or if you want to deploy in your Raspberry Pi, see, Raspberry Pi is a kind of system where we are not having these processor that in my laptop is present. So you can use another version of Kubernetes, that is K3S. So people who want to deploy this in your laptop, just go and Google Minikube install. Automatically, now it's your job, right? You get the first link and choose your operating system. Like, you have your Mac, Linux, or Windows, whatever you want to take. Choose your operating system. Like I have my Mac, you can choose Linux or Windows, and here you can go and follow the steps. You will not face any issues. And this link, in fact, you cannot comment in YouTube, but yeah, you can watch it from there. And if you talk about Raspberry Pi, K3S, another Kubernetes lightweight version that is designed for edge computing and Raspberry Pi, like IoT devices. So here, edge computing, IoT devices, CI, ARMs, and this is your Pi server, right? And how it works, you can understand that thing. So I'm just giving you idea. If you have the learning skills and capability, you guys can go and explore, right? So just information sharing from my end. Okay. Second option is, if you guys are from some company who has their data centers, like Amazon is having some data centers, some customer are having data center, and they want to deploy Kubernetes cluster. So you have option called KubeADM. This is a tool you can deploy Kubernetes, that infrastructure I was talking about, in your virtual machine, in your data center, in your Linode servers, everywhere, by using KubeADM. And the steps for KubeADM, you guys can have it from my GitHub link. So if you go to Google and type my GitHub username, REDASHU, you get that one called K3S. K3S means Kubernetes. And here on the master branch, you can go and follow the steps how you can install Kubernetes cluster by simply using one by one steps, and that's how it's all done. Okay, so you can have this step in your mind. And in fact, in my Amazon cloud, I am running this master minion cluster, and I'm gonna start it. So by using KubeADM, I have already have my cluster in my Amazon cloud, and yes, but the point is you have to follow those steps simply to deploy the cluster, and steps is written for there. So in my Amazon cloud, I have that one, and it will be up in few seconds. I have already deployed it, right? Now, the next thing is, if you are really lazy, you don't want to use Minikube, Raspberry Pi, or KubeADM, you have something else, and where you can deploy in few clicks. And that's where the cloud computing come in picture. So simply, in cloud computing environment, doesn't matter whatever cloud platform you are using, like Amazon, Azure, Google, Oracle, IBM. So I am specifically using Amazon cloud for now, right? But here, there is another method called EKS. So here you don't have to put any extra effort. It's just a matter of few clicks. Boom, 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 right? I can show you one demo. In fact, if you want to create a cluster in Amazon Cloud, I can search for EKS and see Elastic Kubernetes Service, the most trusted way to run Kubernetes, right? And here, literally, you don't have to go for a step-by-step process. And you know what? You can simply continue that. Here, you write the name of the cluster. Okay, master class, cluster name. Next, choose the cluster version from the list and go down, go for the next, then choose your data center, blah, blah, and go. So only 2-3 steps you follow and you get it. You get it, literally you get it. And this is method where you don't have to put any extra effort to create cluster. I'm not doing that, but yes, my job is to give you that information. EKS is there, K3S is there, right? So EKS, Amazon Cloud is having that idea to deploy this thing. So in Amazon Cloud, where my cursor is, in Amazon Cloud, you have a service called EKS, and you can do that. If you have any query, just do ask me over the YouTube, for other purpose. But yeah, you have that one. So simply, I have the cluster ready simply. And when I have the cluster ready, I have to understand one more thing. See, my cluster, if I go to my EC2, and here I do have this cluster, okay? And to connect to that cluster, I'm going to use my browser and command line. Both options are there. So just waiting to load the instances. Yeah, it's running. And see, from my MacBook or from your Linux or Windows, you guys can check. This is a command to connect Kubernetes cluster, get nodes. And yes, just waiting. Yeah, it's connected. Master and minion. And it's simply, it's connected, right? When it is connected, how do I deploy it? Okay, so if I want to deploy the same code, the one I deployed there, what I have to do? What I have to do is, if I want to deploy the same code that I had, HTML code, we have to follow something. Okay, and some steps that I'm going to do it, it is going to kill the job, right? Another thing, if I want to log in, right? If I want to log in from my, in my dashboard, so how do I log in my dashboard? We can, think about that as well. Because if I want to log in my dashboard, how do I do it? I can, check one of my IP address. Okay, I have the dashboard for Kubernetes, https://this : and some port number I have to use. Okay, this is not for understanding that, guys, and don't get bored. But yeah, this is the port number I have. And just to show you here, login, advanced, I have to type this is unsafe, and I get that dashboard. So it doesn't matter you want to connect your Kubernetes from dashboard or from this command line, and this random bigger thing is your password. Password, login. Okay, and I am into the dashboard. See, I can go and check. There may be a few applications will be there, and yeah, remove that. Okay, see, these are some applications are there and they're running. I can choose and deploy so many things here. Fine. So this method I can show you right here. Get nodes. I have 3 nodes: minion 1, 2, and master node. The same thing I'm doing from kubectl get nodes as well. And you get the same, right? Master, minion, minion, master, minion, minion, right? So this thing is, balancing in short. So now one final thing. I need to use that one, and to use it, just give me 1 second time. Okay. So imagine I have the code, and if I go back there, and just to show you, I have the code called HTML code. Okay, you know that HTML code is here. Okay, this code I have to convert into container image. I have to convert into container image. Okay, first process. So how do I convert it? So to convert a code into container image, we have another level of discussion. So if I want to convert a code into a container image, I'm going back to this again here, and we have written something, right? So a normal code, I need to select the right color, and a normal code to container image. Okay, to container image, I can convert by using some technology, and one of the project by Google again is KaniKo. So I can use KaniKo project by Google to convert a normal code into container image. Maybe 80–90% people don't know about KaniKo. In fact, if you learn Kubernetes or Docker is as well, right? Because the standard methods are something else, right? So people who have invested their time to visit this masterclass, I'm giving you a tip to please go ahead and search for project KaniKo, and you get that link, introducing build container image on Kubernetes, right? But this is really awesome, really awesome project. But KaniKo is not that much easy to handle if you don't have much experience. Another option you can go for is, you can go for things like Docker file. Docker file is second option, right? I'm taking code on HTML, by the way, so you can take any other Docker file. And third tool that I'm really using is Builda. So Docker file, KaniKo, Builda, these are the options that you guys can go for. Number 1, number 2, number 3. Okay. I am showing the demo for Docker file, and maybe if the time will allow for Builda as well, right? So here, Docker file. Okay. So what I'll do, I'll take a very little time, and in my code, that code is actually written in HTML, and here I'll create one Docker file and write from Nginx. Just do not try to understand everything. Copy everything to this USR share Nginx HTML USR share, and that's the only thing. Okay, so this much thing I have to write in Docker file, and that's it. So what do I do? To build image, I'm using Docker build -t, like Docker ashu / masterclass version 1, and that's gone, right? And I can log into Docker Hub. So what I'm saying is how easy it is, right? I've written few lines to copy my entire code and build it into this one. This process is called as image building. You can look at here, right? This process is called as image building. And I used the concept of Docker file. So when you attend some, bigger level sessions, we can talk about, okay, what is the concept and what we are writing, but it's just a demo, right? And it got built. Now, if it is built, I have to put this image somewhere from my Kubernetes can take. So when the image got built for us, I have to put it somewhere from where my Kubernetes can take. So if I want to keep my image to somewhere from where my Kubernetes can take, one of the place can be Docker Hub. This is a public storage, or maybe another called QUAY.io. This is also a good place. Other things are there. So I'm choosing by default Docker Hub to store my image, my code image, from where Kubernetes can pick that. So what I'm going to do it, the image I build it, I'm going to log into my Docker Hub account, right? I'm using my username and the password. If it is logged in successfully, oh yeah, it logged in actually. And so what I'll do, I'll push this code to the Docker Hub, and yeah, it's getting prepared. And look at this. In fact, it is getting pushed, right? See, may take time depending on my internet speed, that how good bandwidth I'm having, but yeah, it will be pushed very, very soon. And okay, I'm waiting. Alexa, turn on the lights. Okay.
Master bedroom isn't responding.
Okay.
Please check its network connection and power supply.
Yeah, it worked. Fine. So also, image got pushed. That's nice, right? So finally we build image and we push it. Now from here, I can instruct my Kubernetes to deploy it. So what I do, it's very easy, right? What I do, this image that I got built, I can give it to my master node that is running on my Amazon cloud here, right? And the moment I give that image to this is, a microsecond job to deploy it. So simply, I build one image, I had the code, I integrated with Docker file, then I build it, I upload it somewhere from where Docker Kubernetes can pick it. And look at this. It will take few seconds to deploy and make this website live for you, right? And what I'm going to do it, I'm taking the same image and I'm connecting to Kubernetes. Hey, Kubernetes, create a deployment for me, name it MASTERCLASS, and the image you have to use is, boom, this. And that's done, right? And if I can show you to give me the deployment, it is there, and it is not available right now, but maybe I can just check and check and check. Or if I have given the wrong name, it may continue state, right? So my system are having so much, resource consumption, but it may, take a lot of time to definitely deploy it. Yeah, it's running. So the internet speed is a little slow right now, but yeah, not even 1 minute, right? It's running now, damn running, right? And I can show you the deployment thing is ready. And if I want to make it available to you guys so that you can access, what I have to do is I'm going to expose this deployment to all of you guys, right? in a load balancer way, and done. So what you can do, all of you right now, all of you, right now. So I can try to make it happen like that. So if I'm going to take this port number, okay, and the IP address of my node, let's say any IP address, I'm taking this IP, going there, paste, colon, and this port number. Okay, this port number. So maybe some firewall issues are there, but yeah, it will not take much time to detect. And once it is, I need to maybe enable firewall. Sometimes things are getting in pending state, but it will hardly not going to take much time. I can try with another type, and here I can go and try port, and the name of this is X1. And if I just show you get SVC, maybe it can take some more time, but I can think about that. So my IP address and firewall, if it is not pending that much, I can try it again. Otherwise, I have to look into firewall. But if you talk about the speed particularly, that is really awesome. Okay, maybe firewall or some firewall issues there. I need to enable it. But things is we deployed in that way, and that is running in the running state. Networking is a different problem, but yes, this masterclass thing is running and ready, right? So again, Amazon firewall, I might have disabled it, or yeah, because I have number of instances running. So this is there. I'm not saying that you guys can learn so many things, but information, knowledge, motivation, speed, things are really easy if you go in the right way, that you can feel about, right? So, all right. Now this is, one glimpse about Kubernetes. Another thing that I can take a look is, something called this dashboard that I can show you here. Yes, my pod is running again. Yeah, it's attack and many more things like that. And it's running again. So things are going to be in that way. So next thing that I'm going to relate with Kubernetes is Docker is something that is, having good concept, good things, but there is a replacement for Docker. And that replacement is Podman. Now, people who are already working with Docker, they should understand the Podman very carefully, right? Very much carefully, in fact. So it's a replacement of Docker, right? And maybe in general, not in normal trainings, you won't get the Podman thing. So I have another, machine running named MasterClass, and in this machine, I have my system. So I'm just logging. Give me a second. Yes. So I'm getting it. I'm there. So I logged into that machine, and right here, I have Red Hat Enterprise Linux 8.4. And in this machine, I can install my Podman very much easily. Okay. Although it's already there. Now, people who are already working with Docker, for them, there is one good thing. If you guys are going to use Podman, like Docker, you don't have to start it, right? In Docker, people who are already know about Docker, right? In Docker, you have to start the service of Docker. Now, Podman is something that is serviceless, or better keyword is daemonless, right? So you don't have to start any service in Podman, and the moment you just give that, it is kind of all things. I mean, things are like that. When you install Podman, install and use, install and start using it. Nothing is required. And in fact, I can show you in my Podman, I can see the images. These many images I already have, right? And if I want to create my container, I can see, okay, Podman PS, these many images are running. Okay, so simply, if I want to access any container or access things, so things are literally same as Docker. So from the command line perspective, the commands is got replaced with Podman command, but you just install and start using it, right? You literally don't have to do any kind of starting and all these things right away. Okay, so why Podman is better? First of all, it is not having any service or daemon to talk about. And second, very important thing, if you go to /etc containers, people from Docker background, and there's a file called registry.conf. And this is really amazing, right? Here in registries.conf, you can see one thing, right? From the beginning, if I can go down, Podman is having really amazing feature that, in fact, Docker is not having by default, right? So whenever you are trying to connect with your Podman, and let's say you are searching for some container image, okay? By default, Docker can pick image from Docker Hub only. Docker Hub only, right? So no. If someone is understanding, Podman is an extension of Docker, not at all. It's a replacement of Docker, right? So if you have Docker, I got some question there. It's a replacement of Docker, right? Podman, not the one. It's a replacement of Docker. So Podman has the feature, if you're searching for some image, Docker can search by default only here in Docker Hub, right? But when it comes to Podman, Podman can search image on this registry, on this registry, on this registry. In fact, you can put comma here and write some more options like QUAY.io. So if, example, if I'm looking for some image of database, MySQL or MS SQL, Podman can search here. If it is not found, then it can search here. If it is not found, can search here. Not found, search here. Automatically, it will keep switching. Okay, that precedence we can define. So literally, this feature is not there in the Docker, right? And this is really awesome because you can give number of alternatives to Podman. Second changes for people who are really understanding Docker. Podman is storing its entire data under var containers rather than storing on Docker. So if you are using Docker by default, then Docker store data under var lib Docker. Here it will be Docker, but Podman is storing under var lib containers. So this is for just informative things there. A yes achiever. Podman is a CRE and it's a replacement of Docker that can be used by Kubernetes or by us as well. So like we are using Docker, we are using Kubernetes also. We are using Podman also. So it's up to you you want to use, Docker or Podman or Cryo or Kubernetes, or any other container runtime. So it's a pure CRE, right? And like Docker, you can use that. So this is, some of the information you can think about. Okay, one amazing thing that is really awesome. Okay, one amazing thing that is really awesome. And this thing is really helpful for the people who literally want to start their journey with Podman. Okay, but I have to tell you in some respect, if I am going to use Docker, then it can do few things, like it can create images and it can create containers. Okay, that's it. That is the Docker thing. And imagine if we have a cluster of Kubernetes K3S, then to deploy application in Kubernetes, I have to use some other tool like kubectl. Okay, and the image it got deployed, I have to use that image to deploy in my Kubernetes like I did. So image building and container process is done by Docker, and then I use that image by kubectl to deploy it. Okay, in the replacement, if I would have had Podman, okay, and Podman can also handle image creation with the help of tool called Builder, and it can also create containers. Now, the most beautiful thing about Podman is, listen to that, right? Podman itself can connect to Kubernetes to deploy applications. In fact, Podman can generate your YAML files from a running container. And that feature is literally awesome. So people who are using Podman, they can create container like Docker, they can build image like Docker. In fact, they can deploy that image into Kubernetes by using Podman itself. And the most amazing thing is, you guys can create a YAML file from Podman. It's that much awesome, right? So Neeraj, you're asking something. Podman, see, Kubernetes can use anything that depends on you. Okay, it can use Docker, it can use Podman, it can use Cryo, it can use Rocket. That's up to you. And what Kubernetes version you are using, that depends on many things. So Podman is also a replacement for Cryo and Docker and Kubernetes, not Kubernetes, for CREs. Okay, so this is the one. And I can show you one demo how Podman can create a YAML from a running container, and that is literally beautiful, right? So if I can, just go with thing, what I'm doing, I'm creating a container. So Podman run, and let's say ITT, I can have a name, or master class, FNP, edit 5580 Nginx, right? And if I do Podman PS, right? If I do Podman PS, I get that container right here. So yeah, masterclass container. And from a running container, I can create a YAML for Kubernetes. And how do I do that? Podman generate kube and the name of the container. See, enter. See, wow. It is generating the YAML. people who are already understanding Kubernetes, this information is for them. We have generated YAML where the metadata, app, labels, container argument, command, envs, images, and everything, right? Everything is generated by your, this one. In fact, people who are already aware about service concept in Kubernetes, so what Podman can do, Podman can generate a pod plus service YAML in one shot. And how do I do that? So simply I go there and write -s. The moment I write -s, see, whoa, so it is generating the pod first. If you check here, it is a pod, kind is pod, and you can see here it is first of a pod, and see, kind is pod. And if I just go down, it can also generate service for you of node port or whatever type you want, right? And this label selector is automatically matched. So simply by using single container runtime engine, what you guys can do, if you're well aware about, maybe this information is not that much relevant to people who are in fresher or who are fresher, but yes, when you understand Kubernetes later on, you really miss that session, right? Because generating YAML from a running container is literally amazing, right? So what people are doing, they are creating Docker images, and that Docker images, they are they're just creating a container. Okay, everything is running fine, and when things are running fine, they can generate a YAML out of it and deploy it on Kubernetes by using some CI/CD pipeline. So this is why it is happening, right? So it is likewise. I'm thinking you guys are understanding this thing. A question by Harsh is why Docker Sim support has been replicated since Kubernetes version 1.2 is there. Okay. A big question to the industry people, right? See. So first of all, you might have heard a news, people who are already using Kubernetes for them, right? If you might have heard, Kubernetes has officially announced, right, that they are no more going to use Docker as their Kubernetes container engine, right? And definitely, when you're not using Docker, and IT people, IT industry, they are literally fan of Docker. It was a sad news for a lot of people. And people was like, what the hell? I mean, why Kubernetes deprecated the support since Kubernetes 1.20 was coming in picture, right? And to answer that question, you literally need to understand few things, but I'll try to make it kind of informative for you. I cannot show that practically, but yes. So let's say what Kubernetes need. Okay, so imagine Kubernetes need only a runtime engine. Runtime engine. Okay, so to understand this, I'm giving you one analogy. Let's say you are going to one of your friend and you're asking for, okay, give me your a pen. Okay, a pen. Give me a pen, right? I need a pen. I want to use it, right? And what your friend is doing, he's giving you the pen. That's not a problem. But how? So he's saying, okay, hold the keys of my house or my room, go there, and there is a bag and take that bag, go with you. The bag has laptop, the bag has pen, the bag has copy, the bag has books, and you have to take the entire bag. Then out of it you can use pen simply. So इसको मैं थोड़ा सा कन्वर्ट करता हूँ हिंदी में फॉर यू पीपल. आपको एक दोस्त से पेन चाहिए था, उसने आपको पूरा लैपटॉप का बैग दे दिया, उसमें उसमें लैपटॉप भी है, उसमें कॉपी भी है, उसमें 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 बुक्स भी हैं, उसमें पेन भी है, और बोल रहा है कि मैं पूरा इसे ही दूंगा. You are going to have the entire bag and then you can use it. उसमें से पेन निकाल देना, तुम्हें यूज करना है तो. Then that's the problem. But the problem is you don't have problem with bag. When you contain that bag, you have the responsibility now. Laptop should be safe, copy should be safe. You have to, save from rain. Maybe somebody can, steal that bag, right? मतलब कितनी बड़ी बात है. And the same thing has happened with Docker. So when you install Docker in your system, Docker is giving you so many things. Number one, it is giving you Docker engine. It is giving you the API support. It is giving you the client. It is giving you the SDK support. Once you install Docker, right, it is giving you connectors, right? It is giving you a runtime engine, runtime inside the engine. It is giving you Docker Hub support. So many things it is giving you. And literally what Kubernetes was looking for is this. Out of this entire strategy, Kubernetes need this. And when Docker is giving you that much thing out of the entire, idea, then if any problem happened with engine, with API, with client, with SDK, with this thing, first of all, it's really huge. What we need, we are having so much. Second, if you're having these much things, there is a security issue. When Kubernetes is only looking for this much, why there are so many things? It's a huge, and it's a security issue. So what Kubernetes was using Docker shim to connect with runtime. Okay. And when you're using only this much and when you're having that much, definitely it's a problem. And you know what? What was the runtime for Docker as well? The runtime for Docker was container D. So Kubernetes has not deprecated anything. Kubernetes says officially we are not going to support Docker because Docker has so many things, because it's a risk on their platform of security, of burden, of extra software. But if you can take that responsibility to deal with that security issue, you can use it. And trust me on that, guys. I am using the higher version of Kubernetes, that is 1.21 or 2.0. And that Kubernetes I'm using with Docker on my risk. So the support got deprecated by Kubernetes because they are having this problem. So now containerd is officially promoted automatically. But okay, now containerd was earlier the runtime for Docker itself. So let's only take the containerd and attach in Kubernetes and deal that, right? So I'm sure Harsh, you might have get your answer. And yes, I'm using entire Docker engine in my Kubernetes 1.1 as well. Okay, so that is one thing. And if you're listening, please do respond over the chat room so that I can be on the same page. But yes, that is one of the big thing that we can try to understand. So we really are running out of time, right? But I would love to take one session on entirely Podman and KaniKo, right? So we have few more things that we really want to understand in near future. and you can comment on YouTube channel if you like it, any specific topic, because masterclass is something that we are trying to deliver some unique content, but not everything can practically be done in that short amount of time, but it must be informative. So simply to have that understanding, to keep exploring things, and do let us know on the comment of YouTube. But yeah, I mean, any specific topic, but keep it one, right? So my next plan is to we're gonna talk about two things, two topics: Podman Builder along with the KaniKo, right? So Kubernetes is something that you need a lot of time to learn, right? But is simply Podman that we can really understand thoroughly. So wait for next maybe a topic in near future, and we will be literally understanding it. So thanks for being here, guys. And maybe on your WhatsApp group or somewhere, we'll be having some feedback link. You can just feel free to share the things that you might have faced this thing, and please do comment on YouTube that yes, you liked it or not, so that we can get promoted by number of people to understand it. Okay, so be safe, enjoy this weekend, do not do any study on the Sunday, and enjoy. And if you have your questions, just let me know. Second thing, if you want to get connected with me, because I'm the one who maintain this container technology for you, you can search my name on Google, and this is my LinkedIn thing. I don't know if it's going to be open or not. Yeah, it's right there. Oh, okay. There is a typo. I mean, double H. It will be this. And if you have any question, you can DM me directly, and we'll be having fun. Okay. So bye-bye, guys. See you in next masterclass, and hope you like it or somewhere. It's just about information, right? So bye-bye and have fun. And yeah, do like, subscribe, and comment that a thing for our LNB channel. And that's it, guys. Okay, thank you so much. Bye. I'm dropping off, by the way. So how do I drop off? I don't know. Okay, and I'm just losing the exit, stopping my screen, and boom.